see what we got. Multiplication. And today we are looking at when we multiply by a one-digit number. If we multiply a one digit by a one digit, we just call that a math fact. That's what you've been doing, kind of. 8 times 7 is 56. But what happens when we multiply something bigger like 423 times a one-digit number? What is our algorithm, as we say, to do that? And what you have to understand, people, is I'm sure the way that you've learned this is the way that we all have been doing it for a long time, but what really happens when you do that multiplication, right? I'm sure how many of you have multiplied by, done these problems before, right? You do this, right? 423 times 5, correct? And then you start at the very right and you go, okay, 5 times 3 is?
15.
15, and you put the 1 up there, correct? 5 times 2 is 10, add the 1, which is? 11. You put the, carry the 1 up there, and then 5 times 4 is?
21.
Plus the 1 is 21. Now, what you probably don't realize, and here's where you got to think a little bit in math, is that when you do that, what you're doing is a shortened, condensed form of doing 3 different problems. In other words, when you multiply 423 times 5, what you did when you did all that stuff there was do this. You multiplied, well, first, let's do it first. The first thing you multiplied was 3 times 5. And that's where the 15 came from. Then you multiplied the 5, well, it's the 2, but in reality, that 2 when it's in that place is 20. So you multiply 5 times 20, which is 100. And then the last thing you did was multiply the 5 times the 4, but it's not a 4 because of the place where it's at. You multiplied the 5 times 400, which ends up being 2,000. And if you put all of these together, the answers to all 3 of those problems together, the 2,000 plus the 100 from that place plus the 15 from that place, you end up with the 2,115 that you got right here. So you learned, what you're doing with that is you're learning a really quick shortcut to doing a whole bunch of multiplication problems and then adding all their answers together. Okay, it's always good to do the shortcut, but it's always good to know why that kind of shortcut really works. Okay, so think about that when you do that long multiplication, the short multiplication. Think about this is really what you're doing there. You're taking 400 times 5, adding 20 times 5 to it, and adding 3 times 5 to it, kind of all in one big process. And let me go on record as saying, the better you know your facts, and I see some of you take a lot longer to do those facts that I give you than others, the better you know your facts, the easier it is to get these problems right because it just takes so long. And you can do this with any, I don't know how far you've gotten, but you could do super big problems like 52,345 times, I don't know, 5. I don't know, it's 95, where is it 5? Let's do 6. Okay, and if you don't know even one of your facts, it's going to slow you down because you have to think about it. But it should be very fast. 6 times 5 is 30, carry the 3, 6 times 4 is 24, 6 times 4
is 27.
is 27, carry the 2, 6 times 3 is 18, plus 2 is 20, boom, carry the 2, 6 times 2 is 12, plus 2 is 14, 6 times 5 is 30, plus 1 is 31. Now, you look at this as just doing one problem, but in that one problem you did 1, 2, 3, 4, 5 multiplication problems, and you did 1, 2, 3, 4 addition problems, because when you multiplied in the end, you had to add those things. So if you don't know your addition facts and you don't know your multiplication facts, it makes it really hard to get this problem right all the way through, because you did, I mean, we really did 10 little problems in that big problem there. And getting 1 wrong out of 10 doesn't seem like that much, but if you get 1 little part wrong, you get the whole thing wrong. So if you don't know your facts well, take them home, Have your mom and dad work with you, because you just, did I do something wrong?
Yeah, 6 times 6 isn't
It's
it's
6.
6.
It's a 5. It's a 5. It's just
I hope it was a 5. I thought it was a 5. My big pen didn't write, but it might have been a 6. Did I say it was a 5 or 6 when I wrote
You
it?
said it was a 5.
Okay. It does it there. So let me encourage you to make sure that you know your facts, go home, work on them, because it'll just save you, even though you don't want to do it because you don't have time, or you'd rather play your video games or do whatever. In the end, it'll save you oodles and oodles of time.
I don't play video
I
games.
know. Now, one more thing is, make sure people, if you are doing something like this, what if they give you 35 cents times 7? If we do the math there, 5 times 7 is 35, carry the 3 times 7, 21, plus that is 24. Okay, your answer will not be right if you leave it as 245, or even if you left it as 245 cents. Why? Because in money, you never go to the store and see a price that's 245 cents. Okay, you need to write it like we normally write it. 245 cents is $2.45. Okay. Otherwise, it'd get a little confusing if something was 10,050 cents. You'd be like,
What is that?
What's one?
okay,
What is
I think that's pretty much everything
that?
that's new there.
10,000.